What's up, 7th grade? Mr. Agnos here. My first video wearing my new blue light blocking glasses so that my eyes don't hurt. All right, so today we're going to look at dividing positive and negative fractions. So previously, I believe in 6th grade, you guys learned how to divide fractions, and the method you learned was called multiplying by the reciprocal. So we're going to review that, and then we're going to add in the positive and negative. And the good thing is that the positive and negative we're multiplying. So if the sign's the same, our product will be the same. Our product will be positive. If the signs are different, our product will be negative. So really, we just have to refresh our memory on how we multiply fractions. So I use this word reciprocal. So here's question 1 from the homework, and they give me this fraction, and they say, which of these is the reciprocal of negative 11/7? All right, well, to find the reciprocal of a number, you just switch the top and bottom, and the sign stays the same. So the reciprocal of negative 11/7 would be negative 7/11. The sign stays the same, right? It's still negative, and you switch, right? We switched the numerator and the denominator. Okay. Now, these two fractions are not equal to each other, so I don't want you to confuse that. The word reciprocal just describes the relationship. So I'll give you a really easy example here. 2/3. If I ask you for the reciprocal to 2/3, it's going to stay positive, so we don't write anything, and then I just switch the numerator and the denominator. All right. So that's what it means to be the reciprocal. So, but going back to my original problem here, negative 7/11. So let's see, there it is, choice B, negative 7/11. That's what it means to be the reciprocal. Check answer, got it. All right, on a side note, if you get asked, what is the reciprocal of a whole number? So if they say, what is the reciprocal of 4, for example? Well, remember, we can write whole numbers as fractions. Right? I can write 4 as 4/1. And then to find the reciprocal, you just switch the numerator and the denominator. So the reciprocal of 4 would be 1/4. Again, 4 and 1/4 are not equal to each other. The word reciprocal just describes the relationship between this number and this number. All right, let's check out number 2. Number 2, well, I'm going to skip number 2. It says find the reciprocal of 5/11. Easy peasy. We just flip them, and it's already positive, so I'm going to leave it positive. So the reciprocal of 5/11 is 11/5. All right, let me check out number 3. Okay, so it says write a multiplication expression equivalent to this division expression. So what they're trying to get us to do here is they're refreshing our memories that, hey, when it says 7/9 divided by 11/38, so I have 7/9 divided by 11/38. Well, this is the same thing as multiplying by the reciprocal. So I keep the first fraction, so that's going to stay 7/9. I change division to multiplication, and I flip the second fraction to get the reciprocal. So 7/9 divided by 11/38 is the same as 7/9 times 38/11. All right. This expression right here will give me the exact same result as this expression right here. They're mathematically equivalent. So they don't actually want me to figure out what this is. They're just walking us through each step. So we wrote this division problem as a multiplication problem. A lot of times you will hear this as keep, change, flip, right? You keep the first fraction, change division to multiplication, and flip the second fraction. So keep, maybe if this helps you, keep change, flip. So a lot of times people say KCF, not to be confused with KFC. KCF, keep, change, flip. So anytime you're dividing two fractions, you keep, you change, and you flip. Let's take a look at number 5. Okay, for this example, it says solve for y, and they give us this ugly looking equation here. And we're going to use one of the interesting properties of reciprocals. Anytime you multiply a number by its reciprocal, you get 1. So for example, 2/3 times 3/2. So notice how these two numbers are reciprocals. I get on top, 2 times 3 is 6. On the bottom, 3 times 2 is 6. And 6/6 is equal to 1. This is true of every pair of reciprocals. Let me use a goofier looking one. Maybe I have -4/3. Okay, if I'm going to multiply this by its reciprocal, -4/3 times -3/4. All right, we know that a negative times a negative is a positive. 4 times 3 is 12, and 3 times 4 is 12. 12/12 is equal to 1. So that is one of the interesting properties of reciprocals, is that when you multiply a number times its reciprocal, you always get 1. So we're going to use that to help us solve an equation. So I'm going to rewrite this equation. It says -8/3 times y is equal to 32/3. All right, when we solve an equation, we want to get the variable by itself. And so when I'm multiplying my variable by a fraction, to get rid of that fraction, I just multiply it by its reciprocal. So on the left-hand side, I'm going to multiply by -3/8. And on the right-hand side, whatever I do to the left, I have to do to the right. I'm going to multiply by -3/8. So remember what I just told you. A number, I guess this was our original number right here. A number times its reciprocal always equals 1. So you can do all the multiplication here, right? A negative times a negative is a positive. 3 times 8 is 24. 8 times 3 is 24. So on the left-hand side here, I get 24/24 is equal to y. Well, all of this is just equal to 1. And 1 times y is just y. So essentially, this ends up canceling this out, right? Because it ends up being 1y, which is just equal to y. So now on the left-hand side of my equation here, I have just plain old y. But now on the right-hand side, I have to do some math here. When you're multiplying two fractions like this, we can do some canceling. If numbers have a common factor, we can factor those out. For example, if you have the same number top and bottom, we can cancel those. We know our answer is going to be negative because we have one negative sign. And let's see, 32 and 8, those have a common factor of 8. So if I divide them both by 8, this becomes a 4, this becomes a 1, and 4/1 is just 4. Now, you could have done this the long way as well. You could have just said, okay, 32 times 3 is 96. We know it's going to be negative, and 3 times 8 is 24. And now you have this fraction right here that needs to be simplified, right? This needs to be simplified. And remember, a fraction is just a division problem. This means 96 divided by 24. So and we know it's going to be negative because we have one negative sign. So if I did 96 divided by 24, this is going to go in 4 times. 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus 1 is 9. And remember, it is negative. Boom, so there's my negative. So either way, we get the same result. All right, I'm going to do one last problem. And I just want to reiterate, when I make a video like this, it's not meant to answer every single question there or present you with every single thing there is to know about dividing fractions. Right, you're going to have lots of questions. This is an introduction, and then when you come to class, you ask questions as they come up. All right, find the reciprocal of -7 1/2. So this time they want me to find the reciprocal of a mixed number. Well, the first step in finding the reciprocal of a mixed number is we have to convert this to an improper fraction. So it's negative, so I'm gonna ignore the negative. I'm just gonna say equals. I'm gonna put my negative there, and I'm gonna do 7 times 2. Right? You take the whole number times the bottom is 14, and then you add the top. So that is 15 over 2. So I have negative 15 over 2. So negative 15 over 2 is equal to -7 1/2. And now to find the reciprocal. All right, to find the reciprocal, the sign stays the same, and I flip the top and bottom. So it becomes -2/15. And this is a simplified fraction. So -2 over 15. Got it. Okay. I feel like I covered a lot and I went really fast. Again, you can always go back and rewatch it, slow it down. You're going to have plenty of time in class, right? Make sure you ask questions as they come up. Again, we're working with fractions here, so mixed numbers, we're going to have to convert them to improper fractions. That's always a little challenging. We have to keep our signs straight. Again, if you have an even number of negative signs, they're going to pair up and our end result's going to be positive. If we have an odd number of negative signs, there's always going to be that one that's left out that makes everything negative. If signs are the same, we have a positive result. If signs are different, we have a negative result. So all those things we've been working on still apply. Now we're just doing our keep, change, flip, right? We keep the first fraction, we change the multiplication, and we flip the second fraction. All right, hopefully this video is helpful. Make sure you ask questions in class, and I'll see you guys soon.